Hello boys and girls, welcome to the Math Club. In this video, we're going to talk about mutually exclusive events. Question 7. The Venn diagram shows two events when a six-sided dice is rolled. We have square numbers and numbers less than 4. These two events are here in Venn's diagram. Now let's take a look at the diagram. Now, how many square numbers do we have on a dice? As we said before, we have this and this, 1 and 4. And as we said, that square numbers means what? They are the product of multiplying a number by itself. We call them squared numbers. Now, we have 1 and 4 in one dice, so there are two square numbers. Now, with numbers less than 4, how many do we have? Very good. We have 1, 2, 3. So there are 3 numbers in a dice. As you can see here, the two events are sharing a number, which is 1. It's a square number, at the same time it's less than 4. So here, these events, or these two events, they share a number. So they can happen at the same time. Now let's take a look at the questions. First, as you can see, 5 and 6 are not included inside the circles because they're not square numbers nor less than 4. Now, let's take a look at the questions and answer them together. Question A. Explain why the two events are not mutually exclusive. Now, as we said, mutually exclusive events are events that don't happen at the same time. Now, as you can see here in these two events, they happen at the same time with number 1. So if I roll a dice and I get 1, in that case, I got a square number and a number less than 4 at the same time. And this means they are not mutually exclusive. That's why we explain it by saying they can happen at the same time. That's why they're not mutually exclusive. Now, question B. What is the probability of rolling a square number? Now let's talk about square numbers here. What's the probability of rolling a square number? As you can see here, we have two square numbers. So the probability of rolling a square number is 2 out of 6. Very good. Because we have 2 and all of them are 6. So the probability is 2 out of 6. And then next question says, what's the probability of rolling a number less than 4? As you can see in this event here, a number less than 4, how many numbers are less than 4 in a dice? Very good. We have 1, 2, 3. So they are 3. So I make a fraction, I write 3, and all of them are 6. Very good. So the probability of rolling a number less than 4 is 3 out of 6. Here I have the probability of rolling a square number, and this one is the probability of rolling a number less than 6. Less than 4. Now, next question says, what is the probability of rolling a square number or a number less than 4? So a square number and a number less than 4. Now, first, how many square numbers do I have? We have 1, 2 square numbers. And how many numbers are less than 4? They are 1, 2, 3. When we add 3 and 2 together, they're going to be, how many square numbers? Square numbers are 1, 2, right? So, basically, when you find this probability, you're going to add the ones here, which are square numbers and numbers less than 4. So, how many do we have? Very good. We have 1, 2, 3, 4. So, rolling a square number or number less than 4, yes, because they share this one, I can't count it 2 times, I have to count it 1 time. So I have 1, 2, 3, 4, so it's 4 out of 6. The probability of rolling a square number or a number less than 4 is 4 out of 6. Now the question says, true or false, probability of rolling a square number, which is this one, or number less than 4, I'm sorry, rolling a square number or number less than 4, it's this one, equals probability of rolling a square number, which is this one, plus probability of rolling a number less than 4, which is this one. Is that correct? So he's saying when you add this to this, you will get this. What do you think? Very good, it's false. It can't happen. Why? Because these events, they share this number. And because they share this number, you can't add their probabilities. This is why you can't add non-mutually exclusive events. And this is the answer for question E, for explaining. These events are not mutually exclusive, so you can't add them or you can't add their probabilities. Now, discussion. How can you tell from a Venn diagram whether events are mutually exclusive or not? How can you tell from this diagram if these events are mutually exclusive or not? Very good. I take a look at the middle. If I find something in the middle here, it means that they are sharing this number. And because they're sharing, it means they happen at the same time. And because they happen at the same time, so they're not mutually exclusive. That's why. I hope you understood the idea. And this is how you answer a question like this. What do we understand from this question? We understand that you can add the probability of mutually exclusive events to have or to get the probability of these events together. But if these events are not mutually exclusive, so you can't add their probabilities. And this is how you answer a question like this. Thank you very much for watching. See you next time.